Okay, we're going to talk about more about functions. Okay, and we're going to talk about continuous functions and discontinuous functions. Let's say we have this function f of x is going to be x plus 2. And let's get the other one, g of x. Let's just use another letter. It's going to be x to the square minus 4 divided by x minus 2. So we have these two functions, and let's see what happens with these guys. Okay, so we have two different functions right here. And let's graph the first one. So let's see, f of 1 is going to be equal to 1 plus 2, which is going to give you a 3. F of 2 is going to give you a 2 plus 2, which is going to give you a 4. And f of 3 is going to give you a 3 plus 2, which is going to give you a 5. So no big deal here. Let's grab this one. Let's grab this function. Let's do the little graph here. We'll do it right here. Okay. And we have that this is our f of x, and this is our x, and this is our 1, this is our 2, and this is our 3. And we have 1, 2, 3, 4, 5. So this is 1, 2, 3, 4, 5. So we can let's connect the dots. So we have here, I'll do the x of it right here, x and f of x right here. So we have that for 1, we have 3, for 2, we have 4, and for 3, we have 5. Let's see, 1 and 3, so it's going to be right here. And then we have a 2 and 4. 2 and 4 is going to be over here. And then we have 3 and 5. Okay, 3 and 5 is going to be over here. And we can connect this with a line. And that's the function f of x is equal to x plus 2. And as we can see, they're all, for every x, there's an f of x. So there's a number. Let's do the other one. Let's see what happens with this one. I'll do it over here. So g of 1 is going to be 1 to the square minus 4 over 1 minus 2, which is going to give you 1 minus 4. And this is going to be minus 1. This is going to be minus 3 divided by minus 1, which is going to be 3. Okay. G of 2 is going to be 2 to the square minus 4 over 2 minus 2. And this is going to be 4 minus 4. And this is 2 minus 2. This is going to be 0 over 0, which is not good. Not good. And g of 3 is gonna be 3 to the square minus 4 over 3 minus 2. Okay, which is going to be 9 minus 4, and it's going to be 1 right here, so it's going to throw you a 5. And let's do the graph of this one here. Let's do it here. Okay, let's do our x and our f of x. So this is going to be for 1, we have, it's it's g of x. Let me just change this one here. It's g. So for 1, we have 3, which is the same as the other guy. For 2, for 2, we got 0 over 0, which is not good, not good, not good. And for 3, we got 5. And let me do the graph right here so we can see how it looks like. I'll do it right here so we can compare with the other one. So let me get this one more. I want to make it straighter now. Okay, so let me do this one here. It has to be kind of straight right there. Well, okay. And then you got another one over here. Okay, so let's see what happens with this one. And we have here our 1, our 2, our 3, and the same thing, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And let's do the graph now. Okay, so for 1 and 3, let's see. I'll use the same blue here. For one and 3, so for 1 we got 3 right here. And for 2, for 2 it comes down here. I'll use another color to stress it out. And for 3 it goes to 5. So for 3 we go to 5, which is over here. Okay, let's do the graph of this one here. So it goes like this. Okay. But look here, what's going on with this part right here? Right here, we have an empty space, and then we can continue over here. So if you compare this one is f of x equal to x to the square minus 4 over x minus 2. So if you compare these two graphs, you see you have here something that you do not like. So you have an empty space. So this is a discontinuity. This is a discontinuity. This one right here is a discontinuity. So what can we do to make this graph, the second one, this one right here, to look like the first one? This is the first graph right here. This is graph number A. Let's letter A, and this is graph B. So what can we do to graph B to make it look like graph A? We have to do something. Okay, let's do this. G of x is going to be equal to x minus 2 and x plus 2 divided by x minus 2. Can we do that? Yes, of course, because what we have over here is if you remember from algebra, a to the square minus b to the square is going to be a minus b and a plus b. Okay, that's a difference of squares. We have that relation. You can prove it if you do the multiplication of those guys. So we have this relation right here, the one I'm stressing out here, the one that I'm putting inside the box right here, over here, up here. And we can use it right here. So now we can cancel this one with this one. And now g of x is going to be equal to x plus 2. And as you can see now, if we plug the value of 2 here, it's going to be 2 plus 2. Now you're going to get the 4. So what have you done? So now you have a 4. You can get rid of this one, and you have your 4 here. And now this one is the same as this one. And now the graph is continuous over here. So you have eliminated the discontinuity, and the discontinuity happens here at 2. When x is equal to 2, you have a discontinuity in this one, in the second graph, but you have taken care of that. You have used a little algebra to get rid of the discontinuity. And that's a big deal with functions. You have to be careful because some functions are going to be continuous and some functions are going to be with some discontinuities. They're going to have discontinuities. So you have to be careful, especially with the ones that have discontinuities. And we're going to talk about limits. And when we talk about limits, we're going to play around with functions that have discontinuities. We'll stop here this one. In this one, we would just want to show the difference between a continuous function and a discontinuous function, and how can you make a discontinuous function into a continuous function. And we'll do another one in the next one. Bye.